Right off the bat, congratulations on the Cancer Grand Challenges Award. That must feel amazing.
Thank you. Yes, very much so. It's a real honor, and we were very privileged to receive this award with very stiff competition in the field. Yeah.
Absolutely. Can you tell me more about your winning NexTGen project? How did it evolve?
It really evolved between me and my collaborator and partner here, Dr. Russell Cruz, reaching out to Dr. Stratoff and Pule at University College of London. And we have a common link through our times at Baylor College of Medicine, where we all grew up in the field of cell therapy. And obviously that was really fertile training ground for all of us. And it's just been so wonderful to come together again after all these years. And that's what's so awesome about the Cancer Grand Challenge. It brings together people who may never have worked together before. That we've got a lot of people like that, people who haven't worked together for a long time, and then people from very diverse backgrounds within the scientific realm. And that's really bringing in very new ideas from mathematical modeling, engineering, all the way to cell therapy, immunotherapy, and immunology. And so I think this is what really excites and energizes us to be part of this great team to address the Cancer Grand Challenge of how to better target pediatric solid tumors.
Absolutely. Absolutely. Can you tell me the goals and deliverables for this project specifically?
I mean, our overall vision is within 10 years, we want cell therapy, specifically CAR T cell therapy, to be standard of care for pediatric solid tumors. So that's a very ambitious. But within that, we have 6 work packages which have pretty defined goals. From the first work package, which is to identify new targets specific to pediatric solid tumors that can be targeted by engineered T cells. The second work package 2 is to understand the tumor microenvironment in pediatric solid tumors, understanding there's been a lot of work done in adult solid tumors, but a lot less in pediatric solid tumors. Work package 3 is then to bring those 2 discovery work packages together to engineer the next generation T cell product that will target these new antigens and will overcome the tumor microenvironment, the immune suppressive tumor microenvironment. And then work package 4 will then take those products from work package 3, these new engineered T cell products, and test them in novel preclinical models. So typically, a lot of us just use murine models, but this work package is looking at other sort of preclinical models like tumor on a chip and other models to help us understand how these cells function preclinically. Wow. And then work package 5 is eventually to get these cells to the clinic. But what has set us apart from other grand challenges, we're actually starting work package 5, the clinical trial work package, at the beginning with 3 cutting-edge clinical trials. Wow. Because we know that there's some questions that you can't answer in a mouse or in the test tube. There's some answers that you can only get addressed clinically in the clinic. So we have 3 novel cell therapies already that we want to test in these parallel clinical trials that are being run through the UK and the US. So that's really cutting edge and innovative, and we'll learn from those trials. The other work packages, the discovery work packages, will learn from them, not just in terms of the samples that we'll collect, but also in terms of the outcome data and the immunobiology, etc. And then we have a 6th work package, which is our data harmonization package to bring us all together and make sure that we have data sharing and are able to really make sure that our ideas are not only shared within our bigger group, but then ultimately shared with the community at large. And, we do have real partnership with our patient advocates in our Cancer Grand Challenge team. They are integral to every single work package, and that I think also sets us apart. They all have very unique stories. Many are parents who have lost children to pediatric solid tumors, but we also have a survivor of one of the pediatric solid tumors that we're trying to address, if you'll say. So, it's really so key that we hear from them and understand more, from the community what their needs are as well as part of this. So,
absolutely. That's amazing. Huge in scope. That is
right.
incredible.
It's a grand challenge.
That is amazing. So can you tell me what the $25 million award will do for your team? Which CAR T targets, I know you mentioned 3, are you focusing on for brain cancers and sarcomas?
I mean, right now, the work package 5 clinical trials are going to evaluate a B7H3 CAR T product that we are going to also engineer to render the T cells resistant to TGF-beta, which we know is a real potent immune suppressive cytokine in the tumor microenvironment. So that's the product we're taking to the clinic in pediatric sarcomas and pediatric brain tumors. But we're also going a step further at evaluating the T cell platform that we engineer. So one of the protocols, the one that's being developed at Children's National, we will actually be engineering T cells that are already trained, if you like, to target PRAME, which is a cancer testis antigen expressed quite widely in these pediatric solid tumors. And so this will allow us to compare our approach with the standard approach, which is just expand non-specific T cells and engineer them. Ours are, okay, we're going to expand T cells that we already know are tumor killing and make them even better with gene engineering. So, and we'll be running those studies in parallel with UCL in the same disease. So yeah, I'm quite excited to see, how, the 2 approaches stack up against each other.
Absolutely. Absolutely. Hopefully we'll follow up on that.
Yeah.
And so just as sort of a follow-up to that question, in my very, non-scientific research on the topic, I haven't seen any existing CAR Ts for brain cancers and sarcomas. And in terms of 5-year survival rates in children, it looks about 20% for glioblastoma and 20 to 30% for metastatic Ewing sarcoma, which I know are very severe, types of disease. Is this a primary unmet need in pediatric cancer?
I mean, absolutely. And if you look at the survival curves, even from 30 years ago for children with relapsed refractory sarcomas and brain tumors, they have not changed. I mean, that's how pitiful it is. And, some of our advocates, yesterday we had one of our quarterly meetings, were telling the story about the fact that if their child was diagnosed today, they would relapse today, they would get the exact same treatment that they did, 10 or 20 years ago. So that's how sobering it is about the lack of progress. And one of the brain cancers we're going after is DIPG. And for those children, they only have a median overall survival of 10 months. So this is truly heartbreaking and really, a major area of unmet need.
Absolutely. Absolutely. So what are the unique challenges of targeting solid tumors with CAR Ts? What makes it more difficult compared to blood cancers?
I think one of the main reason, I think, well, there's 2 main reasons. I think firstly, I don't think we've got the right targets yet. For blood cancers, CD19 seemed to be a home run for B cell malignancies. But if you look at CAR T for acute myeloid leukemia, they haven't had the same home run, and it's partly because of the antigens you have to target. And similarly, with solid tumors, this is the same problem, that we just don't have great targets yet. And so that's part of, our discovery work package 1, to really look beyond conventional antigens and look specifically at pediatric solid tumors for what their antigens are they're expressing. So that's one big problem. And then the second problem is the tumor microenvironment, which is really armed in such a way that it's not of great interest for the tumor to have T cells go and attack it. I think, blood cancers, it's sort of more circulating, and maybe it is easier for the T cells to get there despite the tumor immune evasion strategies. Whereas when you're trying to get into cores of solid tumors, which are armed by all these immunosuppressive molecules and cells, etc., that it just makes it a big challenge. So that is why, understanding that tumor microenvironment better and how we can, attack it in a way to make it more amenable to T cell killing is what's so critical as part of our initiative. Yeah.
Absolutely. Absolutely. And similarly, you sort of touched on this briefly in the last question, but you also mentioned in your talk at the British Ambassador's residence that pediatric cancers are biologically distinct from adult cancers. Can you speak more about this, and why can't we, rely on the trickle-down approach from research in adult cancers?
Yeah. So, if you look at the biology of pediatric cancers, firstly, they just don't have the same mutation rate that adult cancers are. So to find these sort of small molecules that have really been a big advance in adult solid tumors is just very unlikely in pediatric solid cancers. So that's why we really need to look at another strategy. In addition, checkpoint inhibitors outside of Hodgkin lymphoma in pediatrics have really had little to no effect in pediatric setting, especially pediatric solid tumors. It's remarkable how little efficacy is shown there. And it's because the microenvironment and what immune cells are present is sort of very different and sparse. And so we have to add more T cells to that environment, and checkpoint inhibitors, which have been a big advance in adult solid tumors, are not that way to address this.
Yeah, that is fascinating. That is absolutely fascinating. And moving sort of back to you and your team, again, you touched on this a little bit earlier, but I'd love to hear more about how the interdisciplinary and multi-center nature of your team contributes to your research.
I really want to emphasize the diversity, because it's not just a bunch of cell therapists who've been collaborating for years, coming together, to do more of the same old. This is, bringing together groups that maybe, as I said, have never worked together or haven't worked together for a long time, coupled with bringing people in from different disciplines, which really makes for very interesting conversations, and really great new ideas are going to come out of this. I can already see that. So that's really, if you like, the secret sauce that we have is the diversity within the group, plus and I can't emphasize this enough, the integral engagement from our patient advocates, because without that community voice and engagement, I don't think we're going to get much traction, because you have to understand a lot of these discovery work packages are going to require parental consent for biopsies and
Yeah.
Sadly, in some cases, autopsies. And those sorts of materials are going to be absolutely key. And so one part of our work with the patient advocates is how to better, inform parents about the importance of, research and sample donation, et cetera, which is key to allowing these discoveries to be made.
Yeah, absolutely. And it's such a hard conversation to have. That's
Right. Especially at a time when, they're the saddest time in their lives. Yeah.
absolutely, absolutely. So more on just you, how has your past research brought you to this project? Again, I know we've touched on it, but I'd love to dive a little deeper.
I mean, so bringing together the TGF-beta story was work actually I did start like over 20 years ago at Baylor, and mainly in the liquid cancer setting. And so this opportunity to now, study it better in the solid tumor setting is very exciting to me. Plus, the platform of being able to target T cells with, the physiologic T cells, if you like, so like the PRAME-specific T cells, to try and use that in a combination strategy with gene engineering is, that's what we're sort of bringing to the table, this sort of ability to bring two platforms together in a very novel way. So these, to me, it's like, this sort of 20 plus years of developing in the field at a time when the field was so young and new, to get to where we are now is really exciting to me. And it's also very exciting to me because we also have younger scientists and trainees and physician scientists in our team, because a big part of our initiative is to train and grow the next generation of scientists and physician scientists in this space. And so I sort of see, what I bring to the table of, years of mentoring the next generation. That's also really exciting because being able to do it at an international level is terrific. Yeah.
Yeah, that is amazing. And finally, what are the next steps for you and your team? I know you went through the modules, but what's coming next?
I mean, the immediate next step is to start the clinical trials. And so we have an ambitious timeline to start in the next, hopefully 6 months. At the same time, currently what we're doing is already there's a lot of work being done on the looking at different solid tumors and looking at the tumor microenvironment in those tumors, as well as starting with the antigen discovery work. We also have some other, engineered products that we want to test preclinically, because we're always, even though we're about to start these upfront clinical trials, at the end of our 5 years, we want to deliver the next generation products. So we need to start now at evaluating what we have preclinically as well. So all of this is going on at the same time. And, right now there's so much activity, and we have our first in-person face-to-face meeting in January. So we're all gearing up to get all our data together to present there, which will be, as I said, the first opportunity for us all to get together in person, which will be really special, and a great opportunity for sharing ideas, etc.
Absolutely. In January will come like that.
I know, right. So that's why there's a lot of work. And, that's why it is so important that we're working with our advocates to help us work with parents and, to be able to get the critical samples and tissues that we need to do these studies. Yeah.
Absolutely. Well, thank you so much, Dr. Bollard. Is there anything that we missed?
No, hopefully I gave you more than enough information, so that we have that we really do believe in our vision, and we really want to deliver on it in the next 10 years. So there's no time to stop.